All right. Good afternoon, everyone. So I'm Sam from U+A Architects. I work as a studio principal of operations. U+A is part of the Egis Group, by the way. As an individual, I carry more than 20 years of experience, and I've worked in various countries like UAE, Singapore, Malaysia, India. And with BIM in particular, I've been involved in this with BIM for more than 15 years, so it was a great journey I had so far. And it helped me to acquire a lot of wisdom, a lot of experience. So presently in my role in this company, I'm more involved into looking into developing, integrating AI, making sure how it is automated with BIM. All right. So let me just quickly introduce you. Right. Sorry. Okay, so just talking about U+A for a moment. So U+A is a multidisciplinary firm that's involved in various sectors, starting from residential, hospitality, master planning, urban design, landscape, interior design. And then when you look at U+A at the broader spectrum of Egis, which has got more than 5 different architectural companies located in more than 20 countries, and almost 950 architects. So looking into that scale of architects, the engineers also separately. So the involvement of BIM is high. So it is the necessity for the company of such a big scale to ensure that we are up with the game. All right. So now let's just have a look back at our AEC sector, which is, as Jerry said, is more than a $10 trillion sector. And if you have seen some research, it would say that more than 30% of the workload of our efficiency is lost in this sector just because of inefficiency or maybe using old technologies or not properly using the data. And that 30% is a big number, as you see. Now, what does generative AI do here for us? Well, with AI-empowered BIM, now we are entering an era of intelligence where the data-driven decisions, predictive analysis, and automated workflows help us to create a completely adaptive, responsive, and resilient spaces. So now let's see, what does generative AI do for architecture? So as generative AI, it helps us to create stuff for architects who deal with creativity. For the BIM professionals, it helps to understand the data. So we have AI tools that, with text, now we can just quickly come up with the mass of the building. For instance, you put a prompt saying that you want a 4-story building or a 10-story residential building, it just pops up. All this with the generative AI. And also, they analyze the work during construction. So there are various AI tools, starting from robotics or your site supervision, the multiple aspects that generative AI is used. So have you ever thought like how generative AI could revolutionize your creative process? Well, just imagine generative AI as your digital assistant that can create text, prompts, codes, images, or even videographs for you. So it basically enhances our creative limits, and it is completely synchronized with the human creativity. So it just helps us to push our boundaries beyond. So if I had to define generative AI as such, it is the artist of algorithmic world. It's a model that uses that operates on the content of data to generate images and videos and codes, as I mentioned. Now, when you talk about generative AI or AI in general, people usually get to know or come to know how is it different from machine learning. How should we look into this? Some people might say that maybe it is AI versus machine learning. Is it both the same? Or some people say, like, yeah, it's exactly the same, it both works together. Or some might say, like, no, it is somewhere different from machine learning. AI and machine learning are somewhat different in their nature. So to answer this, first, let's come up with a definition for AI, I would say. So when you talk about AI, artificial intelligence, so the intelligence is related to humanity. It's a human intelligence we're talking about. And what do humans do? Humans have the ability to discover, they have the ability to infer, and the ability to reason. So when we say ability to discover, AI has the capacity to find new instructions, new informations, ability to infer. It reads the information from different sources and then comes up with its own explanation. And the ability to reason, to figure out things with a logical answer. So now, what kind of things are involved in machine learning? So I'll start with a Venn diagram to tell you how we can put it all in context together. So in machine learning, it is a model, it is a capability of a model to understand instruction and provide decisions based on data. So the more the information, the more the data that you provide, the more accurate data that you provide, the better, the more accurate result that you get it from. So if I say machine learning, there are again two types of machine learning. One is supervised, where manual inputs are required, and the other one is unsupervised, which completely runs on the codes and logics of algorithms. Now, interestingly, these machine learning, it doesn't need like all these people with the knowledge of code to come up and work on machine learning, because the codes are already preset. But this is a learning capacity, which means we are not interfering with the codes of anything in machine learning. It learns by itself. The code is as such, the algorithms are as such. The more the data that you provide, it learns and it comes up with its solution of responses. Now, one more thing that comes, many of you might know, is deep learning. So what is deep learning in this context? Well, I would say like deep learning is a subset of machine learning, which means deep learning, if you look at the broader picture, it has got neural networks. So it works just like the human synchronization of brain, like neurals and networks, and it has a completely, it was completely designed in a way that it comes up with a logic that we cannot define. So what it does is it comes up with surprising answers. Maybe with deep learning, we come up with solutions and imaginations you would have never thought about it. Maybe you would have never thought of such logics. At the same time, I would say disadvantage is you can't go and challenge on the deep learning how it arrived to such decisions. So it is just providing a completely new insight, which might just surprise you. Well then, so how does AI fit in this? Now we defined AI and machine learning. So AI, I would say, is a superset of machine learning, which means the machine learning along with deep learning is built within this AI context, along with NLP and LLM. So NLP is natural learning processing, and LLM is large language modeling. So these two are basically the features that understands the language text that runs on the scripts. So these, you can call it as like the machine of an engine, or the machine of a car or something. Now, I don't want to go deeper on the technical terms of LLM, but in simple terms, you can take NLP as one of your old phones. The usage was simple. You just make a call, receive a message, that's it. It was straightforward. It has one input, one output of a solution. But LLM has a complex of NLP within it. So it has multiple networks of NLP within that, and that's how it is able to process multiple megabytes of data at the same time. Well, then again, when we talk about human intelligence, we have vision. So AI has the capacity to come up with vision, creating images, text to speech. So the AIs are so adapted that now there is no barrier of languages. They can adapt to any of the languages we talk about. So when you say human can talk, so the text to speech is more related to the speech version of it. And then the motion. Motion is definitely, people move around, they carry things. So in AI, you can take it to robotics. So on site, you can see how it's been used for 3D printing. So this all works under the motion category. So the right way to put across would be the machine learning is a subset of artificial intelligence. Now, as of today, when we are sitting around, you can see there are a lot of pre-trained transformers like ChatGPT, Midjourney, architectures, then Revis tool. So there are multiple generative transformers wherein it works with prompts. You don't have to dwell too deep into the technical aspects of it. So as per my analogy, I just look into this way. So Gen AI is your car, the generative AI is your car. The LLM, which is a large language model, is your machine. And the prompts, you're the driver, so you have to prompt, you have to tell how to go, where to go. So you define your goals, you define what you want out of it. So prompt itself is an engineering. It is very important in generative AI that your prompt needs to be accurate, more informative, so that you get the right result. So there are multiple ways you can create your prompts, but we come up generally with a simple strategy. We call it as create. So what does create means? So when you're creating a prompt, give a context to it, set a context. For example, I'll give an example. It's like given the rise of the AI tool. So I'm just creating a prompt. I want to put it in ChatGPT. Unfortunately, I couldn't run it here, but I'm just setting up an environment of a prompt here. So first is the context. Second, request. So you state your specific request. So I stated first my context is generative AI tools. My next request is I'm interested in learning effective ways to incorporate AI tools in architectural workflow. So that's my request, what I want from it. Then you set examples with illustrations. You can say, like, could you share some real-life examples for successful AI? So you're making it more specific for the generative AI tools to understand that it has to look for certain examples to prove its output. Then analysis, you can always request for an explanation, saying along with the detailed analysis, how you have to make them how it works. Then takeaway, like you inquire about the key takeaways, what you're going to get out of it. And then enhancement, how you can enhance it. So this is not like a golden rule or something, but it is more informative. So when you set these sort of parameters for the prompt engineering, you get an absolute good result as much as possible. Yet again, prompt engineering is very human-specific. Each person has their own goals, and it changes as per the need. I'll just take you through one quick example of how this prompt engineering worked within our office. So first, this is a basic framework, as you see on my left screen. So I used Midjourney here to generate a visual. So I set only 4 basic parameters, saying style, subject, description, and parameters. The style, I want an architectural photo. Subject, of a luxury mansion. Description, well, I'm thinking of a New York-ish style mansion. And then I can set parameters, what is the aspect ratio that I want, whether the style has to be raw or fine controlled. So we can create such prompts. And then when we enter in the Midjourney, I don't know how many of you can see, it creates a mansion. It is good enough, but maybe that's not what I want. I want to define it a bit more. So then I go to the next level, which is the developed framework. So here, if you see, I'm adding a bit more of information. I'm talking about location, time of day, keywords, color palette, like tonalist cream, mint green, arctic blue, time of the day, blue hour, location, middle of nowhere. So I'm giving more information to see like how much more I can get out of it. And the result, well, it's more subtle. This is reaching there, but still it's not there yet. Maybe I'm still looking for more details of this image. So then I go with the complete fine control framework, where there are a lot of information I'm putting in, like what is our inclusion and exclusion, what is our composition. So I don't want to dwell too much, but I'm adding a lot more information of what all the type of looks and the fields that I need. And then I get a crisp image. So now you see, the more you refine your prompt engineering prompts, the more you refine your prompts, the better, the more accurate output you get. Now, this is one of our, now as I said, like we do in-house training, we promote AI in our studios. So we held a competition, we just made some group of architects to come up with an idea. Our topic was reimagine shelter beyond Earth, 50 years, 100 years down the lane. In the future, how housing would look like. So these are some of the works which the team came up. They started with some basic framework of, they took some images as a reference, they put it mid-journey, the color tone they selected, some sketches they did, and then they created the prompts. And then this is how the journey looked like. So this was one of the final results. Yet again, this is just one of the examples. There are multiple teams with different visions, different aspects, the way, the outlook, the prompt. The goal was the same. Everyone was looking for beyond the shelter topic, but everyone's vision was different. So it all depends on the prompt, how you feed it. It could be as funny as having a duck haven, or it could be as good as imagining a shelter hanging from moon, like rope it up. Well, now, the problem with generative AI, in real world, it is very good for conceptual architects. They would love it because they want to create quick images, generate mood images. It's well and good. But the problem with generative AI is it does not have context. It does not have a setback, site plan, space programming, feasibility, code compliance. So it's just image. How do we deal with this? Because as architects, we work within the site limit constraints, and we have to make sure like we are doing realistic things. We can't just throw random buildings in anywhere or everywhere. So we collaborate with this one of the firms called Evolve Lab, with whom we closely work with, and they offer a lot of AI tools. So for instance, this is one of the tools wherein you see like the mask is created on the SketchUp mode. You create different masking, and then the moment you keep changing your masking, your prompts, with the prompts you see like we keep changing our prompts, how we want it to look like, and the renders come up quickly. Now this is more realistic because this is what you want to see, like you create a model, you give a tone, you give your language, a style, and then it generates the image. So this is now more contextual. Similarly, there is this tool within Evolve Lab called Veras that supports not only SketchUp, but Rhinos, Veras, AutoCAD, Revit. So all of this, for instance, again the same, that with SketchUp, with simple masking, you set the tone and you get quick output, even for interior design when they try to come up with some sculptural elements or room furnishings. You come up with a very quick render within a matter of 5 to 10 minutes. Of course, the more you spend your time, the more pace you get. But it's much more easier to convince the client with a vision, the realistic renderings. Now, predictive analysis. Now, predictive AI is a bit more away from generative AI, where we are setting the constraints and we are working within the constraints. So this would interest more of the architects, engineers, and contractors, which is a bit away from the creative field, but more on the documentation style. So when concept is done, we get the SketchUp model. It takes months or weeks at least, a couple of weeks at least, to translate this SketchUp model into a Revit. Now with this tool of Helix, it's just a quick plugin. 10 minutes, your SketchUp model is transferred to Revit with all its families and parameters set in. Yes, you have to refine further, but as a quick build, you can set your levels, everything with the prompts, and it generates your Revit. Same from Rhino or AutoCAD, anything, even from the AutoCAD plane, two-dimensional plans, it can generate the 3D models right away within like minutes of time. Now, these are some more examples which I just included to show like even with the live model, unlike it's not just one way, it's a live link. So even if you modify SketchUp, you can always link it back, and that updates your Revit. So you don't have to go and track your changes. You just relink just as you do in any of your Revit models. Reload your link, same concept. Reload your SketchUp, your Revit model gets updated. And the good thing is this also generates a list of the changes. So that's even more helpful for the BIM modelers or the BIM professionals who work with it. Now, when we talk about an industry which is dwelling on a lot of projects, multiple projects, and we have a vast amount of BIM team having 10 to 20 people working on big projects, Many of them are working on repeated tasks. That's what I said, like 30% of our industry is losing their efficiency just because they're doing repeated tasks, outdated data. But how it can be automated? For instance, a day-to-day routine, create plans, create elevations, tag dimensions, create sheets, put into the view. This is the daily task. Now, how it would be that you have your model, you set up the prompt, and you then get it generated through this AI that does all this task within 10 minutes for you. So your model is ready. 5 to 10, again, I'm just elaborating because it depends on the scale of the project. But as small as this, it can take maybe a couple of minutes, and there your drawings are ready. So this is what we're looking at. And one more example, tagging, annotations, multiple taggings, like when you're talking about curtain walls or scheduling. Just with a prompt, it comes up, runs the prompts, just tell them what exactly you want to do, where the tag should be placed, and that's it. It tags all the documents, it's done. You're reducing your manual effort here, you're saving on your time here. So that was one of example that I said it was a back-to-back process, wherein like we do one task at a time. But yet again, the same tool, which is Glyph from Evolve Lab, you can bundle it up. You can do multiple tasks, not only just automate creation of view, auto dimension, put it on the sheets, a complete drawings all together, full package to be done. You can just automate with the prompts. Just you need to make sure your prompts are being modified for every project as per the need, and you get whole of your documentation done with AI, no manual input. So now, you might think, so is AI going to take away our jobs? No. AI on its own with its own capacity of its machine modeling or its computational capabilities, that is not going to take away the job. But yes, people with the AI knowledge, they would take away the job. Because AI, we are just entering a generation wherein in the next 10 years, it's going to expand much beyond our limit. And if that is not surprising enough for you, I just mentioned about quantum computing, because this is the next generation of computing we're talking about, where we translate our journey from digital computing to quantum computing. Working from bits of 0 and 1, we're talking about a quantum physics, a quantum computing, where you're going to get things done much faster. And this is not far away. As of now, we are talking about already in Silicon Valley, companies like IBM, Google, say in Amazon, anyone you name it, Intel, they all are competing to get this quantum computing out there in the market. So it's time that we embrace this journey, get upgraded, so there is no, as Jerry said, there is always a tendency of 5% people going away. But it all depends who is ready for this game. All right, I hope you liked my journey so far. Thank you so much.
Thank you ever so much, sir. Thank you so much.